What is sustainability? One way to think about this term is through the lens of a concept called the triple bottom line: people, planet, and profit. It takes the idea of annual profit, the end result of all transactions, and incorporates the impact a business has on people and the planet. It's a way of ensuring that when we assess a business, every aspect of its impact is covered and that profit doesn't come at the expense of people or the environment. When we talk about sustainability, we're adding the future as a component, ensuring that we take into account the impact our actions now will have on future generations. A commonly agreed upon definition of sustainability comes from the UN World Commission on Environment and Development: meeting the needs of the present without compromising the ability of future generations to meet their own needs. The idea is that we have a responsibility to future generations to allow them the chance to enjoy the same prosperity and quality of life that we do. To be clear, when we talk about meeting our needs, we're talking about human beings using resources, anything that we use to our benefit, to survive. Everything from breathing the air, to using water from a lake or stream, to cutting down trees for wood. To demonstrate this concept, let's engage in an exercise. Imagine you and I are farmers, each with a herd of cows. We both send some of our cattle to graze on a shared plot of land called the commons. The commons is lush and green, with plenty to eat for the cows we choose to send, and the grass regrows at a steady and predictable rate. This is a sustainable situation, one that we could engage in indefinitely. But if one day I decide to double the number of cattle I send to the commons to feed, the balance is disrupted. My cows eat more and more of the grass, quicker than it can regrow, and the commons isn't quite as green as it once was. On top of that, you decide it isn't fair that I should get to use the commons more than you, and you too decide to double the number of cows you send. Soon enough, the commons is completely depleted, and neither of us can use it for grazing at all. This is the tragedy of the commons, the concept that multiple individuals acting independently will ultimately deplete a shared limited resource, or commons, even when it is clear that it is not in anyone's long-term interest for this to happen. Where have we seen this concept play out in the real world? Examples of a shared limited resource include bodies of water, the air, and soil, anything that belongs to everyone and no one at the same time. The tragedy is that because no one owns these resources outright, no one is directly responsible for their well-being, and as a result, these resources are perpetually at risk. Of particular concern when we discuss tragedy of the commons scenarios are non-renewable or finite resources. These are things we cannot expect to replenish or regenerate in our lifetimes after they have been used. Fossil fuels, energy sources formed beneath the earth over millions of years, are a primary example of a non-renewable resource. Oil, gas, and coal are all fossil fuels and were formed over the course of millions of years. Although they are still forming, albeit very, very slowly, beneath the surface of the earth, we cannot expect them to replenish in our lifetimes. These fuels are capable of storing a very large amount of energy by volume, which is why they are the energy source of choice in our day-to-day existence. But in addition to being finite and non-renewable, fossil fuels also release a certain amount of greenhouse gases when used. Greenhouse gases are a naturally occurring group of gases in the Earth's atmosphere that blanket the planet and trap in heat provided by the sun. The process by which the Earth absorbs and retains heat from the sun is called the greenhouse effect. As the sun's rays hit the Earth, a few things happen. Some of the heat provided is absorbed by the planet's surface, some of it is reflected back out into space, and some of it is trapped in by the atmosphere. Greenhouse gases are essential to life on human Earth. Without them, the average temperature on the planet would be about 0 degrees Fahrenheit. However, an excess of greenhouse gases can cause the atmosphere to trap in too much heat. Carbon dioxide is the primary greenhouse gas emitted by human beings. It enters the atmosphere in a variety of ways, including through the burning of fossil fuels. Although carbon dioxide makes up only a small part of the mix of gases in the atmosphere, it is primarily responsible for its ability to trap in heat, and thus the concentration of carbon dioxide in the atmosphere, which we are increasing through our consumption of fossil fuels, has a large effect on the planet's temperature. Methane is another greenhouse gas emitted by human beings which also contributes to the atmosphere's ability to retain heat. As organic material decomposes, it often releases methane. This is especially relevant to us in the Parks Department. Dead and decaying trees emit large amounts of methane if they are allowed to decompose naturally. One of our parks, Fresh Kills Park in Staten Island, is actually built on top of a landfill. The methane being released by the organic material beneath the surface is captured and converted into a usable energy source. If we look at the atmospheric concentration of carbon dioxide over the past 800,000 years, we see that for the vast majority of the Earth's history, it has never fallen outside of this range of approximately 170 parts per million to 290 parts per million. You can clearly see that the point we're at presently represents a departure from the norm, that with regards to atmospheric carbon dioxide, we are in uncharted territory. If we zoom in and look at the last 60 years, we can see that the concentration of atmospheric carbon dioxide is currently far outside of that range. We have been over 300 parts per million for decades and just recently passed 400. In this animation, you can see how global average temperatures have changed over roughly the same time period. Red represents a 2-degree increase of average temperature, while blue represents a 2-degree decrease from a baseline in the early 20th century. Over time, you can see that the planet as a whole is getting significantly warmer. By 2013, almost the entire map is a bright red. Many experts believe that this shift in the global climate is a direct effect of human activity. Before we go any further, it's important to note the distinction between weather, which is the current state of the atmosphere at any given time, and climate, which is an extended pattern of weather over many years. One rainstorm is an instance of weather. The average amount of rainfall in a given part of the world is a part of its climate. The climate of a given region of the world refers to the types of weather we can expect to see. When we talk about climate change, we're talking about a change in global climate patterns that can be attributed to increased levels of atmospheric carbon dioxide brought on by human consumption of fossil fuels. As the climate changes, it sets into motion certain positive feedback loops, processes that enhance or increase the change. One such feedback is the concentration of ice in the Arctic Ocean. This ice helps to keep the planet cool, as ice is extremely effective in reflecting sunlight back into space, decreasing the amount of sunlight absorbed by the planet. As you can see in this animation, Arctic sea ice goes through a natural cycle of increases and decreases throughout the course of the year. However, the total amount of ice present in the Arctic Ocean has greatly diminished over the past 3 decades, which means the planet reflects less sunlight and absorbs more of it. This means warmer temperatures, which causes more ice to melt, which means the planet reflects less sunlight, and so on in a loop. Another positive feedback loop is the melting of permafrost, a layer of frozen soil beneath the Earth that contains organic material from thousands of years ago. As the planet gets warmer, this permafrost will melt, which will cause the organic material contained within to thaw and release greenhouse gases, which causes the planet to warm further, which will cause more permafrost to melt, and so on in a loop. These loops are part of why climate change is such a big issue. It is a phenomenon that builds on itself. But even if the climate is changing, why is it such an important issue? What effects can we actually expect these changes to have on our lives? Climate change as a phenomenon is very broad and difficult to accurately measure or predict, partially because these changes are happening across the entire planet, a complex and interconnected system in which everything has an effect on everything else, and partially because it's completely without precedent. We don't know how the planet is going to react to these changes because we have very little to compare them to, but there are certain things we can expect to see. One is an increase in extreme weather and severe weather events. These two directly affect one another. Severe weather events include any event with the potential to cause property damage, displacement, or the loss of life. This is an image of flooding in North Carolina from Hurricane Matthew in 2016. This storm, a severe weather event, produced more than a foot of rainfall and caused massive flooding as the ground was unable to absorb much of the water after an abnormally wet September. This is an image of the 2016 wildfire in Fort McMurray, Canada, which burned nearly 1.5 million acres of forest. The fire began during a period of extreme and abnormal dry heat in May of 2016 and burned uncontrollably for over 2 months. This wildfire is an example of a severe weather event brought on by extreme weather. In addition to extreme weather events, climate change can reduce snowpack, the ice and snow that accumulate at higher altitudes during the winter. Many places rely on this water to replenish reservoirs when it melts in the spring, but as temperatures have risen, they have seen less and less accumulation. This image shows the decrease in snowpack accumulation in Yosemite National Park from 2012 to 2015. As ocean levels rise, coastal areas will become more susceptible to flooding. This is an image of a flooded street in Miami Beach. While the city is attempting to reinforce sinking streets and install pumps that will allow water to be removed during floods, the measures are proving costly and it's unclear whether they will be effective. These and other effects have the potential to profoundly impact human beings for many years to come. Extreme and unpredictable weather, along with increased water scarcity, makes agriculture more costly and difficult. This image shows the effect of an extended period of drought on a crop of soybeans in Texas. Rising temperatures, shifting precipitation patterns, reduced snowpack, and increased drought frequency all have effects on the availability of fresh water. This image shows Lake Mead, a source of water for more than 30 million people. In 2016, the lake was at its lowest level in 80 years. Coastal areas are especially susceptible to the effects of climate change. As sea levels continue to rise and severe weather events become more frequent, coastal areas will become more and more susceptible to flooding and storms. This is an image of the aftermath of Hurricane Sandy, which caused over $68 billion in damage across 7 states. Critical infrastructure systems, from roads, highways, and bridges to subways, are also vulnerable. This image shows a flooded subway station after Hurricane Sandy, which caused over $68 billion in damage across 7 states. These damages are especially impactful because they are so essential to everyday life. The extreme temperatures brought on by climate change will increase the amount of energy used for heating and cooling, energy that primarily comes from the burning of fossil fuels. This will in turn increase pollution and greenhouse gas emissions. This is an image of the Ravenswood Generating Station in western Queens, the largest power plant in New York City. It runs primarily on natural gas. So what can we do about all of this? Strategies for preparing for and combating climate change are typically split into 2 distinct categories. Mitigation, which includes any and all efforts to reduce or prevent emissions of greenhouse gases and avoid further changes to the global climate, and adaptation, which includes any and all efforts to reduce vulnerability to the effects of climate change and prepare for future changes. New York City Parks sustainability training will mostly focus on mitigation, methods of reducing energy usage and pollution, as well as increasing energy efficiency and reducing waste.